welcome back to physics. And today we are going to start our last small topic before the midterm, which is momentum.
A small topic. Momentum. The definition for momentum is mass times velocity. Literally, this is what it is.
And that's all you really do to calculate it.
It's the definition and the formula. Now, the only confusing thing is that for the symbol for momentum, we use a lowercase p. Not a capital P, that's period. Actually, no, it's not.
It's power.
It's power, sorry. Lowercase p is momentum, and the formula is mass times velocity.
Okay, so this is an equation that's on the back of your reference table. P equals mv. P is defined on the back of your reference table as momentum.
The other weird thing about momentum is it doesn't have its own unit. Its unit is the unit of mass times the unit of velocity, which is just kilograms times meters per second. It would be nice if momentum had its own unit, but it doesn't.
Which is also kind of nice, because you don't have to memorize what it becomes. Like with force, we're always saying, okay, well, we have to remember that that becomes newtons. All you have to do is take your kilograms times your meters per second, and that's going to give you your units for momentum.
So momentum is very closely related to inertia. And in fact, a lot of the questions that you get about inertia can sometimes be momentum questions as well, or you can confuse them between each other, inertia and momentum questions. Like, for example, when we started talking about inertia, and we started the whole physics thing, we started talking about which object has the highest inertia, and we gave you some masses and some masses with velocity, like a truck at 10 meters per second, or a truck sitting still. Which one has higher inertia? And if as long as it's the same truck, they would have the same inertia. But if we're talking about momentum, the truck that has a velocity has a higher momentum. Why? Because momentum is mass times velocity. So let's do a quick practice. What is the momentum of a 100 kilogram student running at 2 meters per second? Well, you would write out P is equal to m times v. Take that 100 kilograms of mass and multiply it by 2 meters per second, and get 200. And the units would be the units of momentum, kilograms times meters per second.
Now, this will get a little bit more complicated. We're going to get into change in momentum. And then we also talk about what happens when objects collide into each other. We won't talk about that until after your midterm. But just know, yes, this does start out really simple. It will get a little bit more complicated, so just keep that in mind. But for right now, talking about momentum, you just need to realize momentum is going to be mass times velocity. We have this equation on the back of our reference table that we're going to use, and be able to do some straightforward practice problems like this.
Now also notice that they could give you a mass and give you a momentum and ask for a velocity. Or they can give you a momentum and give you a velocity and ask for a mass. So you can basically solve for anything that's in that equation. So even though it looks really simple, they're going to throw a bunch of numbers at you and try to make it look more complicated.
So just be careful with what they're giving you, what your units are. Make sure that you're looking forward to seeing what exactly they're asking you to solve for. And the biggest point, like Mr. Petersek was saying, is to make sure that you're able to distinguish inertia and momentum between each other. Okay? In real life, real world, a lot of times we do kind of think of momentum similar to inertia and the tendency of an object to keep moving in that same direction. The term that we use is, oh, they have a lot of momentum, which they do, but they are slightly different things that we have to keep in mind and make sure that you're able to distinguish between them. But I think that's pretty much it for our intro to momentum. A nice short video just to give you the vocab and the basics of it so that we can get a little bit more complex in class tomorrow.
Have a good night. Yes.